All right, let's dive right into a really fascinating problem. How do we take all this messy, human-centric stuff, documents, articles, readmes, and translate it into something an AI can actually make sense of? It's all about building a bridge between our world and theirs, and let me tell you, it is a huge challenge.
I mean, just look at a standard README file for some software. For you and me, it's easy, right? We see headings, code blocks, instructions. We get it. But for a machine, it's just a giant, meaningless wall of text. So how in the world does an AI figure out that this is a key feature and that is an installation command? That's the core problem we're going to unpack today. So, the project we're breaking down today had one super clear mission: to build that bridge, to go from messy, unstructured text to clean, organized data. The goal was never just about pulling out words. It was about truly translating human knowledge into a language that an AI could speak natively.
And this, right here, this really gets to the heart of the vision. The whole idea of a digital twin for knowledge. That's powerful stuff. Just imagine, for every piece of documentation out there, there's a perfect, machine-readable version of it, one that can be instantly searched, questioned, and understood by literally any AI system on the planet.
Okay, so what about the first try at building this bridge? Well, here's the thing. It technically worked, but as the project's own blueprint put it was a house of cards. Yeah, it looked okay on the surface, but it was incredibly fragile, just waiting for the slightest breeze to knock it all down.
So the foundation was shaky in three really big ways. First, the code was brittle. It assumed the document's layout would never change. So one tiny edit by a developer, and boom, the whole thing breaks. Second, the logic was hard-coded, meaning it only worked for one specific document. And third, the algorithm for finding answers? It was basically just guessing, using a confidence score that had no real mathematical basis. It was a prototype, sure, but it was not a real solution. That failure, though, it led to something great. A complete refactoring. A total teardown guided by a whole new philosophy. The goal now was to rebuild the entire system from scratch to be resilient, flexible, and, well, intelligent. Basically, to build it the way a senior engineer would.
And this slide just perfectly captures that huge shift in thinking. The old way, this fragile scraper, it expected everything to be perfect and would break at the drop of a hat. The new method is a resilient parser. It doesn't assume anything. Instead, it intelligently reads the document's context, using headings to figure out what's what, just like you or I would.
So how does this actually work? It's a really simple but incredibly powerful idea called a state machine. The parser just reads the document one piece at a time. When it hits a big heading like installation, it flips a switch internally, setting its state. From that moment on, it knows, okay, everything I'm reading now belongs to the installation section, at least until it hits the next heading. It's just a really elegant way to understand context without being super rigid.
And this is where that resilience becomes so important. What happens when the document isn't perfect? For instance, the README they were working with was missing a features section. The old scraper would have just thrown an error and crashed. But the new parser? It had a plan B. It intelligently grabbed all the main headings from the document and used those as a substitute feature list. It was built to expect failure and handle it gracefully. But look, having structured data is totally useless if no one else can understand what it means. And that's where schema.org comes in. Think of it like a universal dictionary for machines. By using this global standard, the project basically gave its data a universal business card. Now, any search engine, any AI can read it instantly, no custom programming needed.
And the result of all this work is that digital twin we talked about at the beginning. It's not a messy text file anymore. It's a perfectly structured, schema-validated knowledge graph. Everything has a clear label, from the project's name and description right down to the installation URL. It's clean, it's precise, and it's finally ready for an AI to actually use. Okay, so we've got this perfect knowledge base. Awesome. Now, how do we ask it questions? To make that happen, the query engine, the part that finds the answers, had to be rebuilt to be just as smart as the parser.
The old, totally flawed algorithm was thrown out and replaced with this much smarter two-part approach. The new confidence score is a weighted blend. 70% of the score comes from matching critical keywords that reward specific, direct answers. The other 30% comes from phrase similarity, which rewards answers that kind of have the same shape and flow as the question. Blending these two gives you a super reliable 0 to 100% score that's way more accurate.
The whole user experience got a massive overhaul too. Gone was the clunky one-and-done command. In its place, an interactive session. Now the knowledge graph loads into memory just one time, and you can fire away, asking question after question and getting answers instantly. And when I say instantly, I really mean it. The measured response time was under 100 milliseconds, literally faster than you can blink. This incredible speed isn't just a cool party trick. It's the ultimate proof that the entire system, from that resilient parser all the way to the intelligent query engine, is lightweight, efficient, and just brilliantly engineered. So, we've walked through this project's journey from a fragile house of cards to this robust, intelligent system. But why does this matter in the grand scheme of things? Well, the impact of making knowledge truly AI native is immediate, and it is absolutely huge. For starters, this kind of structured data dramatically boosts your SEO, letting you get those rich search results that really stand out. Even more importantly, it provides a factual ground truth for AI assistants like ChatGPT, which helps prevent them from hallucinating or just making stuff up. And finally, it creates a single source of truth that can power better developer tools and way better documentation for everyone. In the end, this journey was about so much more than just one piece of software. As the architect so perfectly put it, we have not just built a tool, we have lit a path. A path forward to a future where all human knowledge has its own digital twin, making it not just accessible to machines, but truly, deeply conversational.